Hello and welcome! Does something look wrong with the camera? Let me take a look. Do you know what this is? And why does it make everything so colorful? Keep watching to find out. So do you have any idea what this disc is? It doesn't really look like much, even up close, a piece of plastic surrounded by cardboard. But when you look even closer, and you even look through it, it's much more interesting than that. So what if we put this peephole back up in front of the camera? What do you see? Look at these patterns created by the string lights. What if you look at this flashlight? What do you see now? What colors do you see? Are they random or in a pattern? What if I move the flashlight closer or farther? Do they change? What if we rotate the peephole? So what is this, and why does it make everything so colorful? There is a tiny pattern etched into one side of the plastic, but this pattern is super tiny. Look at the scale. The bumps are only 2 microns. Do you know how big a micron is? Or rather, how small? A human hair is only about 30 to 80 microns, so 2 microns is so small that you can't see or even feel it. But if it is that small, how can we even have a picture of it? Well, this image was taken with something called an atomic force microscope. Optical engineers and physicists make these, and they use the tiny, tiny forces between a material and a probe to map the surface of that material, even when the structures are so small a normal microscope can't see them. Okay, so now that we've talked about what this is, where do you think that all those colors you were seeing come from? From the peephole? Well, they actually come from the light itself. Because white light isn't absent of color, but rather it's a combination of all the visible colors. And when you look through this peephole, those tiny bumps I was showing you splits up the light based on color. This is called diffraction, and it's the same reason you see rainbows on the back of a CD, for example. So this peephole let us see all of the different colors in white light. We saw the effects from the string lights and the flashlight, but let's take a look at some other light sources while we're here. This is an incandescent lamp, like you might find in your house, with the glass globe and the little wire filament that produces light. And when you turn it on, you can see it just produces white light. And when we put the peephole on, you can see that strong spread of rainbow colors. Take a look at this cool pattern. So if the peephole shows us all of the colors in white light, what do you think we'll see if we put a colored light in front of the peephole? So this is a mercury vapor lamp. There's mercury gas, and you run electricity through it to create light. If I turn it on, you can see that the light is clearly green. Now what do you think you're going to see when we put the peephole back up? Now what do you see? Do you see these green rectangles? Note how they're less of a blur, and they look more like the original light source. This is called a monochromatic source. Mono meaning one, and chromatic referring to color. So it's a light source that emits only one color. That's why you only see the green through the diffraction grating. Now the last source I'm going to show you is another vapor lamp, but this one is helium instead of mercury. So if I turn this on, what color does it look like? It's pretty bright, so the light itself might almost look white, but if you look at the light in the back, you can tell that it's a pretty orange light. So what do you expect to see when we put the peephole back up in front of the camera? So, what do you see now? There isn't just one color, nor is there a whole rainbow spread, but instead there are a couple of separate lines that are each different colors, starting from like a blue, teal, moving out to like a yellowish orange, and ending with like a red. These different colors actually make up the color that you're seeing out of the lamp itself. It's not monochromatic like the mercury source, even though it appears colored. Now, different element gases all have a unique set of these colors. So if you look at a lamp like this through this peephole, you can tell what element is in it just by looking at the light that it produces. Now, mercury, the element in the green lamp, also has a unique pattern like this called its spectrum, which is shown here. Can you see the different colored lines? In the lamp I just showed you, we put a filter on to isolate just this green line so that it was a source with only one color. So what is diffraction good for? Well, one modern use is in telecommunications. We just showed that light can be separated into many different colors. Well, if you code one person's conversation into one color, one wavelength of light, and send it through something like a fiber optic cable, you could separate it out from another person's if theirs was in a different wavelength or color. This means that large numbers of people can be communicating all at once. Each person's conversation is contained in one color, so they can travel together and then the wavelengths can be separated back out at the end. People in this field work in what is called photonics. They find ways to use light to transmit information instead of electricity, which makes it much faster and much more efficient. Before using photonics for communication, we passed electrical signals through copper wire. But electricity travels much slower than light, about 100 times slower actually. And that's the difference between jogging at 5 miles an hour and flying in an airplane at 500 miles an hour. Photonics has brought huge improvements, and not just in telecommunications, but also in imaging, healthcare, and many more fields than I can list right now. But the moral is that photonics is one of many fields that is changing the world. So if you are interested, there's a lot more to learn.